Okay, so in this video we're going to have a look at another short question on probability. So it's a question 3, section A. So we're told here attendance at a local rugby match depends on the weather. So the probability of a large crowd attending if it's raining is 0.35, and then the probability of rain on a match day is 0.3. We have a question here, part 1, what's the probability of rain and a large crowd? So the minute we see the word and, it means we're going to multiply. So essentially what they're asking us to find is the probability of rain, which is 0.3, and the probability then of a large crowd is 0.35. So the probability of rain and a large crowd. Again, the word and tells me to multiply. 0.3 by 0.35 into your calculator, and you get back 0.105. And that's our answer there for part 1. Pretty straightforward for 10 marks. Part 2 then, a little bit more here. They say the probability of a large crowd attending is 0.8, and we're asked to verify that the probability of a large crowd attending and rain occurring are not independent events. So what that means then is that, like we looked at in the last exam question, if they are independent, then it will mean that the probability of a large crowd intersection rain will equal the probability of a large crowd multiplied by the probability of rain. And we're just going to use our workings essentially from part 1 to help us with this. So they tell us here the probability of a large crowd is 0.8. The probability of rain, they had told us above, was 0.3. And then we had figured out in part 1 the probability of rain and a large crowd was 0.105. So first thing I'll deal with here is this part. So we're going to have 0.8 times 0.3. So there's my workings there for the right hand side of the equation. So 0.3 by 0.8 will give me 0.24. And we just need a little statement now that 0.5 is not equal to 0.105 is not equal to 0.24. So, and our written statement now. So therefore, the probability of a large crowd plus rain are not independent events. That's done for part 2 for 5 marks. Part 3 now. Change the topic. So they tell us there's a bag, has 15 coloured discs. 6 of them are blue, 4 of them are red, 3 are yellow, and 2 are green. Okay, so part 1 says what's the probability 4 discs are chosen at random, and then find the probability that 4 of the discs are blue. Okay, so what's going to happen here is another thing we're going to assume is if they're pulling discs out of the bag, that when the disc comes out, it's not going to be replaced. So that means we'll have 15 and then 14. So then there'll be 14 left. They'll go again, 13 left, and the last time there'll be 12 left. And they want to know what's the probability the 4 discs are blue. So if we check, we have 6 blue discs. So my first time I got to take it out, I pick one of 6. Then there's 5 left, 4 left, and 3 left. So we put that into our calculator. 6 over 15 by 5 over 15 by 4 over 15 by 3 over 15. Sorry, 6 over 15 by 5 over 14 by 4 over 13 by 3 over 12 will give me 1 over 91. And that's my answer to part 1. So the probability of 4 blue will equal 1 over 91. Okay, part 2 then. The probability that the 4 discs are the same colour. So our conditions for that means then it can't be green because we only have 2. It can't be yellow, we only have 3 of them. It could be red or it could be blue. So if it's going to be blue, blue, blue and blue, or we have 4 reds. So we know from above, we figured it out. So the probability of 4 blue equals 1 over 91. And then the probability of 4 red. So same principle as part 1. For red there's 4 of them. So when we first pick there's 15 discs. We have 3 red left and 14 discs. 2 red left and 13 discs. We've run 1 red left and 12 discs. And we're going to put that into our calculator. 4 over 15 by 3 over 14 by 2 over 13 by 1 over 12. We get quite a large number. That's 1 over, or quite a small number, quite a large denominator, 1 over 1365, and then we're going to add them together. When we see the word here, or, means add. So we get 1 over 91 plus 1 over 1365. We'll get 16 over 1365. Okay, that's our answer to part 2. And part 3 now, we're asked the 4 discs are different colours. Okay, so our options here is the first disc could be, we'll say blue, we'll write it in the order they gave us. Then we could have a red disc, then we could have a yellow disc, and then we could have a green disc. And because I have 4, we're looking at our arrangements here. I have 4 discs and potential discs, and this is the different ways we can arrange them. So then we're looking at 4 factorial ways. Okay, so first thing we'll do is figure out for blue, we get 6 over 15. Then we have 14 discs left, 13 discs left, and 12 discs left. And then if I pull out a blue one, 6 over 15, a red one, there's 4 red, so that's 4. For yellow I have 3 yellows, and then I have 2 greens. So that's going to give me, into our calculator, 6 over 15 by 4 over 14 by 3 over 13 by 2 over 12 will give me 2 over 455. And then we multiply that by 4 factorial. So that's the different ways that I can arrange it. And again, just enter your calculator. We will get 48 over 455. And there is my answer to part 3. So now, a longer way, I suppose, of answering this question would be if you went through each separate scenario, but that would take quite a while. So it'll look something like blue, red, yellow, green. So if we ran through maybe all the ones starting with blue, it'd be blue, red, green, yellow. Then you could have blue, green, red, yellow, blue, green, yellow, red. Then we can have blue, yellow, red, green. And that's the combinations done for blue. Then we'd run through our options for red, and then for yellow, and then for green. So it's 4 colors. We have 6 orders, we'll say, per color. You could use your fundamental principle accounting here. So that's 24 options. And then you'll note as well, if you put into your calculator 4 factorial also will give you 24. So anyway, that's that question answered. And we have another short question done for 30 marks.